You guys okay? Okay, go ahead. So just talk about the chemistry of the weak acid. So this is just a very classic, and in the old days, that's how I learned when I was a student. And of course, this is now it's oversimplified. So we say we have a weak acid. So this is any weak acid. So using the symbol HA, it's very classic. So any weak acid. So we'll dissociate a proton, and of course we know that this does not exist because the proton and water will come together and form the hydronium ion. So that's the actual. But for simple, we just say proton H plus. And then we have the A minus, which is the anion, and that's the conjugate base. So it goes back and forth because it's a weak acid. Because it's a weak, it's not completely dissociated, so that's why it's weak. So it will be back and forth. Back and forth, then you have the equilibrium, and that is a K, capital letter K. So capital letter K. In before, when we talk about the kinetics, the rate constant is also K. That was a lowercase cursive K. So do not get confused or mixed up between the two. These are two different things. Two different. This is equilibrium constant. And A stands for acid. All right. So how we write the expression would be the product, which is the proton concentration, and then the conjugate base and the weak acid. Now this is the equilibrium expression. Keep in mind all this concentration should be at equilibrium. At equilibrium. It's not any concentration, it's the concentration at equilibrium. So let's get you straight out one more time. Equilibrium constant K. HA, what do we call HA? What do we call HA? Weak acid. Weak acid. How about the proton? All right, so that's the proton. And this is the conjugate base. Now, while this proton will be picked up and can be reflected or can be represented by called pH. So that's that. A lot of the time I see students get confused with the proton and the weak acid. So proton is the pH. The weak acid will give you proton. The proton is not acid. Right? A lot of this is acid. That's not acid. That's proton. This is acid. And further, we should say weak acid, specifically. Are we okay? So that's super important. All right. Okay. Now, with that said, we will come back to this. All right. So let me see. Now let's take a look at the worksheet. Then, okay. Okay. I lost the mouse. Okay. I don't know why. All right, so here's the worksheet. All right, so you guys fill it out as you know the top part. So let's talk about task one. All right. So if you have the lab menu and so if you have the lab menu, all right, so task one. Now, well, before we go that far, so please read off the lab menu from page 68 and 69. You see, that's something what I just talked about. Of course, in here, the lab menu is more formal and correct, and saying the weak acid react with the water and give you the hydronium ion. And while in here, me just shorten that part, and the lab menu is more, is correct. In here is a quick form of that. All right, so we have the titration curve, equivalent point, and then on page 71, same thing. I just look at the figure, tells you how to identify the equivalent point and the half equivalent point, which I will talk about later. And then that's the buffer zone and so on. All right, so all this learn and study. And the acetic acid, the Ka is 1.8 times 10 to minus 5, and the pKa is 4.74. Yeah. All right, so those are the constants provided, and then how to solve the hydroxide concentration and so on. So all that. All right. So what is the pH definition? All this in the lab menu. Okay, task one. So if you would recall what we did on day one, so we make the 1 molar sodium hydroxide from the 6 molar sodium hydroxide we provided to you, and then we want to standardize that, and we use KHP, which is a very, very famous universal. Anywhere you go, people know it. Potassium hydrogen folate, such a well-known and famous primary standard. All right. So we use this chemical to set the pH. So this is the what I call the origin. So everything is made and built and come out from this chemical, because this is a very stable chemical and can be very pure. And so we use it to find out what's the base concentration, and then using the base to find the acid. So back and forth. Anyway, so if you look at just the quick, we say because the solubility of the KHP is 10.2 gram per liter, that's the most you can dissolve. So we follow that maximum solubility. So that means 10.2 for 1 liter, but we are not using 1 liter. we use 500 ml of the solution, half of a liter, so therefore we use 5.1 grams of the KHP. I don't even have the ponder. So that's that. So this is example. And then you're going to use the 500 ml of your KHP and you to standardize your sodium hydroxide. So your burette is filled with your sodium hydroxide around 1 molar, and you are going to add sodium hydroxide into the KHP until the color change to pink from colorless. And you are going to record that amount of sodium hydroxide. So this is example, all right? All these are example. So I say it's 25.02 milliliter, for example. And of course we convert the milliliter into liter, yeah? So that's that. Yes?
So we have to convert it to milliliters?
So you probably better using liter because the unit of molar is moles per liter. Yeah. So I know in your burette is milliliter. So you probably is 25 something, but here I just say 25.02. Okay? Now, your burette can read down to the second decimal place. So it should be 4/6 as much. Okay? All right. Then what? Then what you are going to want to find out what is your concentration of your sodium hydroxide. Now, well, I can ask, how about this? Anyone volunteer? Give me your data. How about that?
For the second one, I got 25.1 milliliters. I need to convert it again.
All right, 25
Point
on 1?
yeah, milliliters.
All right. So 25.1. All right. So then what? Then what you're going to do is 5.1 divided by the 204.23. What is 204.23? What is that? Where is that come from? That is the molecular weight of your KHP. Yeah? So we need the molecular weight. So molecular weight is moles per gram, and this one is the volume, and okay, so let's see. What are you going to 10 divided by 204, 1, 2, 3, and then divided by 0.0250. Okay? So that is the concentration of your sodium hydroxide. Now you know should be around 1, and you got 0.9949. I would, yeah. So in here I would say really is 0.9949. Now of course that's 4/6 in here, and if we look at the mass, your mass is 5.10 or more 6 in here? What one?
Yeah. Yeah.
Okay. So for you, then you have to recalculate. Okay. That will be your concentration. And you may have done second and third trial, and then you would have, each of your concentration. And here we'll take the average of the 3 or 2. So make sure, we know how to do the average, right? So you add all 3, if you have 3, and divide by 3. And the plus minus will be your standard deviation. In here, that's fine. If you have 3, if you only did 2, then the plus minus is not very meaningful. Then I would not bother with the plus minus if you only did 2. Okay? If you did 3, then you can have standard deviation. 2, I mean, of course, 2 you can still do, but it's just not very meaningful. Of the plus minus. Are we good? All right. Okay. Then, task 2. Oh, task 2. Okay, let's go to task 2. Yeah, task 2 is a little funny. I put it in the second page. All right. Okay, task 2. Make sure you write down the unknown number. I know I probably had forgot to ask you guys write down the unknown number. I don't know you guys did or not, but yeah. So tell me your unknown number, and then now you did the titration with your sodium hydroxide. So here is the example, and I have this file, Excel file, posted in the island already. So again, let me emphasize, this is a sample. It's not belong to you. It's not yours. It's not what yours. All right. So this is only a sample. However, you may enter your volume in here. So at your 0 volume, that means you didn't do any addition of sodium hydroxide, whatever your pH may be. This is example. And I don't want to keep on saying, all right, everyone. So then you enter all your volume accordingly and your pH accordingly. And the graph will pop up and pop out. All right, so if I change to this, you see, it changed. It changed to 5. So it will change. So the good news, and to spoil you a little bit, is you just enter and plug in your data there, and the graph will be yours. Are we good? Now, make sure you get the title. This is, of course, not the title. So your title should be something like unknown weak acid titration with your sodium hydroxide. In here, I write down 1 molar. For you, may not be 1 molar. Remember, you may be 1 point something. Oops. So you should write this number, whatever that average number. Yes? Instead saying 1, because you are not 1, I say 1 in here, it's just example. Okay? All right. So that's your titration curve. Now, once you have the titration curve, so we want to identify the equivalent point, or endpoint, excuse me. So the endpoint is right at the sharpest change. So you will see a jump, or the change of the rapid change of your pH, and the middle of halfway of the jump, that will be your endpoint. Now the point, it's little misleading. You look at this example, there is no data point in here. No data point in here. But that is your endpoint. So people sometimes, that's the point. So using a data point, NO, we are not using a data point. You are using a point on the curve. Are we good? Not using a data point. All right, so that is the point on the curve. Then what? We want to know the volume at that point. So the volume at that point will be 22.75 in this example. Then you say, how can I get that? Now, everyone look at here. You look at my cursor. Look at my cursor. You see, when I point it at, they tell you. Now, of course, this is 3 sig figs. Now we had 4 sig figs. That is because we did something else and got this back. So if you're really using the Excel, you may only get 3 sig figs because they run it up to you, for you. So, it's 22.8 in this example. Then, you go to the worksheet in here. All right, so the worksheet in here, we ask you, what is the sodium hydroxide concentration? So, that's the concentration you get average up in the earlier page. And the mass you use for your unknown. So maybe 2, I just write 2.11 can be, some odd number like this, yeah. Now, then the volume at the equivalent, at the endpoint. So if I use the example in here, it will be 22.75. So this will be 22.75. Are we good? Now, then we say, what is your molecular weight? How you calculate your molecular weight? So you use the mass of your unknown you used, that's the gram, and we know molecular weight is gram per mole. So what's the mole is the volume and the concentration multiplied. So volume times the concentration. So here's the volume in liter times the concentration. So basically, it's talking about the concentration times the volume. yeah, and the mass divided by that. So this number will be using the three numbers in the above. All right, but how is that? That is the mass, the gram, divided by mole. Mole is the volume times the concentration. That will be your molecular weight. Are we good? Now, one more. And we say what is the pKa? How you learn the pKa is to find the half equivalent point. So here is the equivalent point in my example is 22.8. So 22.8, I'm going to divide that by 2. So once you have the endpoint, so once you have the endpoint, you go down to the volume of the endpoint. So here's the volume. You find this volume and you're going to divide it by 2, cut it half. So then you come to here, that's the half volume of endpoint. And then you go up there and take a reading of the pH. That pH is equal to the pKa. Are we okay? So, using this example, so it's 22.8 and divide by 2 would be 11.4. So I will go to here, try to get, oh, okay, so 11.4. Everyone, no, yeah, 11, well, 11, not 11. So I got 11.5, kind of close. So 11.5, the pH is 4.11. Therefore, for this example, the pKa would be 4.11. Around there. To be exact would be, yeah, I can go to the 4. So it would be 11.11 or a little bit below would be 11.10 in this example. Okay? So then you're going to write down the pKa in here, so by using this example would be 411. Are we good? Now, 2 more boxes. Then they say, what's the literature value? All right? What do we mean? What's the literature value? So that is in the lab manual. So that is on page 79. So we have a table in here, a list of different unknown weak acid, and with the formula, and then the Ka. Everyone see that table? So I recommend you need to do a little homework. We provide you Ka. Then you are going to log each and all of the Ka and times -1 to get the pKa. And now in this one, your pKa is 4.11, and then you hold your pKa and then come to the list and see which one you are close to or match to. Then you claim your unknown weak acid is that weak acid. Is that okay? Now, same thing in here, the molecular weight. So this one, I just say, all right, so let me just calculate, using the data in here. Of course, it's not true, okay? So 22 divided by 1.02275 and divide by 1.01. And so my molecular weight is about 92. Everyone see that? So using this data, of course, then my molecular weight is 92. Now, we provide you the formula in here. You can calculate each and all of the molecular weight of all the lists. Yeah, I know you need to do homework, okay? Then you hold your 92 and see which one you match or get close. Then you say your unknown weak acid is that weak acid. Now keep in mind what we had is two pieces of characteristic. One is your Ka, one is your molecular weight. And hopefully the two come up the same. Yeah? You hope and suppose to be the same. If they are not the same, I would pick the pKa better or trust the pKa more. Because I know your sodium hydroxide, because I was asking you were using, assuming everything is 1, and I know some of you come out the data is not exact or close to 1, even maybe far away from 1. Are we good? Okay. And so that's